Okay, so Jai Krishan, let's proceed ahead with your mock for thermodynamics, and that is for Bhabha Atomic Research Center, right?
Yes, sir.
So, can you tell me something about internal energy?
Yes, sir. Internal energy is the energy stored in the system, and it is usually the sum of the kinetic energy, potential energy, and various intermolecular energies like translational energy, rotational energy, vibrational energy.
When I keep a glass of water in the fridge, what happens to its internal energy?
So the heat is taken from the system,
Hmm.
and as a result, the internal energy uh, of the of the glass of water reduces, sir.
Hmm. So, what happens to the molecular energy?
Molecular energy also reduces.
What kind of energies molecule carry?
So, uh, in real sense, molecules are not uh, is moving always.
Hmm.
It has some rotational energy. It has some translational energy due to motion, and it also has vibrational energies. And there is nuclear energies like that also.
What is the difference between heat energy and work?
Um, Both are energy in transit, and heat is a form of low grade energy. Work is a form of high grade energy.
Hmm. Why this is called low grade?
Because heat cannot be completely converted into work, but work can be completely converted into heat.
Can you suggest me some methods through which heat is converted into work?
It is converted into work, sir. Sir, it can be converted into work. Uh, Heat engine, sir.
Heat engine.
Yes, sir.
Any other method other than heat engine? Have you heard about thermoelectric engine?
Thermoelectric. Sorry, sir.
Have you heard about Seebeck effect?
Feedback effect, sir. Yes, sir. Used in thermocouple, sir.
What is that?
Um, Due to the temperature difference, uh, an EMF is generated in the body, sir.
Mhm. Okay. Do you know there are different kind of thermometers?
Yes, sir.
Thermocouple is also one type of thermometer.
Yes, sir.
On what principle is this based?
Thermocouple, sir.
Yeah.
Thermocouple is the principle is that whenever there is a temperature difference, because the thermometer will be at one temperature and the temperature which have to be measured will be at another temperature. Due to this temperature difference, an EMF is generated in the device and which can be measured using voltmeter.
Can you name some different type of thermometers?
Sir, there's a usual thermometer which uses mercury, and there is constant volume gas thermometer. There is
Mm.
constant pressure gas thermometer.
Mm. How can you make a thermometer in the kitchen? You don't have anything, no measurement device and all. How can you create a thermometer in the kitchen?
Mm. So 0 degrees Celsius, 100 degrees Celsius can be measured. That between
Have you heard about gas thermometers?
Constant volume, yes, sir.
Have you heard about gas thermometer? Constant pressure, constant volume gas thermometer. Have you heard about that?
Yes, sir.
What are these? Why do we need gas thermometers, Jai Kishan?
So the constant volume gas thermometer gives the temperature in the Kelvin scale.
But why do we need?
Need,
Okay, can you tell me something about second law of thermodynamics equation? Equation of second law of thermodynamics.
Okay. Okay, sir. So cyclic integral dq by dt less than equal to 0.
No, equation I want, not inequality. Write it in the form of equation.
Okay. Sir, delta S is equal to integral dq by t plus S generation.
What is DS generation?
Entropy is generated within the system.
And how do we calculate it?
Can sir, from this equation, sir, from the equation of the second law, we can calculate.
Okay, do you know how to calculate entropy change for universe?
Entropy change of a universe is the sum of the entropy change of the system and the entropy change of the surroundings.
Okay, now let me give you a case here. There is a glass of water.
Okay, sir.
And we are heating it.
Okay.
We are heating it on, let's say, gas, and we are supplying some heat energy to it. Tell the entropy change of system, entropy change of universe, entropy change of surrounding, and entropy change of universe.
Entropy change of the system will be Q divided by T, and entropy change of the surroundings will be where T Q is equal to minus Q divided by T.
But how you are getting Q?
So we are adding heat, sir.
But how shall you calculate that heat addition?
So this equation is applicable only if, in case of the reservoir, but in case of glass, the temperature is changing as a result of the heat addition, and so in that case, the entropy change will be MCL and T2 by T1.
That is for glass water, right?
Yes, sir.
But what about surrounding?
What about, sir?
Surrounding. Entropy change of surrounding.
Yes, sir. We can calculate Q is equal to as a change of the internal energy of the glass of water, sir, which will be equal to MC delta T.
MC delta T. From there you will get the heat.
Yes, sir.
And then how to calculate entropy change of surrounding?
Entropy change of surrounding will be that minus Q divided by temperature of the surroundings.
And how to calculate entropy change of universe now?
Inverse now will be that temperature, that entropy change of the system plus entropy change of the surrounding.
Okay, can you tell me something about entropy principle?
Principle. The principle entropy of the universe always increases.
At the equilibrium, what will be the entropy?
Equilibrium, dead state, sir.
Yeah, not equilibrium. Yeah.
At dead state, the temperature will be the entropy will be maximum.
Okay, and when the entropy is maximum, what is the meaning of that?
Entropy is usually the measure of the irreversibility of the system. And the more entropy means it is more irreversible.
Okay, now let me give you another case. There is a container of water, and then you are putting stirrer in that. There is a stirrer in that.
Okay.
And stirrer is stirring the water.
Okay, sir.
How shall you calculate the entropy change now?
Work is being transferred into the system. And as a result, entropy is generated. Same case, sir. As a result of the work, the temperature of the liquid increases, and we can use the equation of the entropy change.
In terms of temperatures, huh?
Yes, sir.
Okay, tell me something about enthalpy and flow work.
Enthalpy is the sum of the internal energy and the specific flow work.
What is flow work?
Flow work is the work required to maintain the flow.
Flow of what?
Flow work, sir.
What if the fluid is not flowing and it is at rest?
Yes, sir.
Then let's say the fluid is not flowing and it is at rest.
Yes, sir.
In that case,
also, sir, it is the work required to make the fluid flow.
Okay, can you tell me first and second law of thermodynamics, when I connect together, what equation do I get?
So we can say it will be TDS is equal to DU plus PdV, or TDS is equal to DH minus VdP.
Okay, so this PdV and VdP, these are the works, huh?
Yes, sir.
So if I give you PdV minus VdP, can I say this is a thermodynamic property?
No, sir.
What about PdV plus VdP?
PdV plus VdP is thermodynamic property.
How do you say that?
Because property is exact differential functions, and mathematically PdV plus VdP can be solved to be comes up to be exact differential functions.
Can you tell me something about the throttling process? What do you understand by that?
Throttling is basically the sudden pressure drop occurring, and as a result, there is no the enthalpy remains constant during the throttling process.
But how do we get that equation enthalpy remains constant during throttling process?
Because during throttling there is no heat transfer, neither work transfer.
Can you give some example of throttling process?
So the flow of liquid through a small area duct,
Capillary, yeah?
capillaries.
Why do we use it?
Capillary is used in refrigeration process for throttling, VCRS.
How the expansion takes place in capillary during throttling?
So there is pressure loss.
Why the pressure loss is there?
The pressure is losing due to the friction.
Why the friction is there?
Friction occurs due to viscosity.
Okay, do you know something about free expansion?
Free expansion. Sir.
Give the example.
Sir, busting of tire, cooker seal, pressure cooker seal.
What remains constant during free expansion?
Internal energies.
How can you find that from steady flow energy question?
Can I consider the system is adiabatic, sir?
Okay. Okay, tell me the mechanisms by which you can get adiabatic process.
Adiabatic process is a process in which there is no heat transfer, and it can be achieved by using non-conducting material.
What are the different mechanisms to get some process which is adiabatic?
Making the walls adiabatic, and that is also there. Otherwise, there will be heat transfer.
Okay. What about fast process?
Okay, sir. Fast process are usually considered for analysis. Usually consider that as a adiabatic process.
Why fast processes are assumed to be adiabatic?
Because some time is required for heat transfer to occur. Heat is energy in transit, and if that not time is mentioned by fast means faster than the time required for heat transfer to occur.
Is throttling process adiabatic?
Throttling process is adiabatic.
Is throttling process adiabatic?
Yes, sir.
Is it fast process?
It is an irreversible process, so I think it is fast.
No, it is slow process.
Okay, sir.
Why then it is adiabatic? Why is this adiabatic then? Being slow. What is insulation and isolation? What is the difference between the two?
In insulation, the heat transfer to the system will be zero. During isolation, there is neither heat interaction nor work interaction.
Okay. And what is isolation?
For isolation, there is no heat transfer.
Which one is a perfect adiabatic system? Isolation or insulation?
Both are adiabatic, sir.
Okay. Okay, let me give you the feedback now, Jay.
Okay, sir.
That is okay. I mean, your level is better than last snap which I had. You have improved, and the way you are answering is also improved.
Okay,
But
sir.
just keep on revising more and more, right?
Okay, sir.
Because there is no limit what kind of question can be asked. So just keep on revising,
Okay, sir.
right? Keep revising and keep learning about more concepts of thermodynamics and go for more snaps. Huh?
Okay, sir. Sir, that throttling process are why slow?
Throttling is actually a slow process. It goes through slow, but why it is adiabatic is because space is not there for heat to transfer. So you
Okay,
don't
sir.
provide the space for heat to flow. That is the point,
Okay, sir.
right?
Okay, sir.
Okay.
Thanks.